Uh, so hello, is my screen visible? Okay. So today I'll be talking about XGBoost, also called Extreme Gradient Boost. It is a boosting technique and a very high performance boosting technique otherwise. Uh, so so let's okay. So before going straight into the working of this XGBoost, uh, in the layman terms, I want to try to explain you about the whole scenario, what happens inside this algorithm. Okay. So uh, suppose I want to, in my holidays, I want to visit a place for a vacation, perhaps Goa or Manali or something or any other place. So I have not been to that place and I want to go there. So I will try to take some information from my friend. I think that he has been to that place and he will give me some valuable information. Suppose I asked my first friend and he gave me some information, but 10% was right and 90% was wrong information he has gave me. So he told me that wait a second, I'll ask another friend of mine, maybe he can tell us something about the place. Then when he asked his friend gives a little bit more information than the first friend, but still he was also unable to give me the whole information. Then what happened? That friend also told that he will ask another friend who may give me the whole information. Then the third friend was actually been to that place and he gave me a maximum information about that place, that you can take this type of clothes, you are visiting, go by this road, go to this restaurant for eating, or stay in that hotel or something. He has helped me a lot and he has gave me maximum information. Okay. So what is happening in this whole scenario is the error that the first friend have given me actually is getting boosted step by step. Okay. With the increasing, or when I am increasing the number of people that I'm talking to, the error is decreasing. Okay. The same thing, the same scenario is happening inside this XGBoost. Okay. So let's start. So I have taken this data set, a very small part I have taken. There is this column, age column, and the salary column. Age is 24, the salary will be 21,000. 32 age, 1,20,000. 41 age, 90,000, and 29 age, salary will be 80,000. Okay. So this is my data set. The first step of prediction, this data set, when we put inside the XGBoost algorithm, the first week learner will try to do the prediction, and that first week learner prediction will be this. It will just be a mean of this output salary column. Okay. The first learner will tell that this is the prediction, and that will be the mean. Okay. Then it will calculate the residual or error of that first week learner. Okay. Which will be the actual data 21 minus the predicted data, that is 77.75. The number is this, residual will be this. So for every row this will be calculated. Okay. Then the work of the first week learner is done. Then it will be sent forward to the second learner. Okay. So the second learner will take this age column and a residual. Just forget about these two column now. Age column and residual it will take and try to create and try to do the prediction. Okay. Now what it will do is it will try to create a tree. Okay. The second week learner will try to create a tree. That this is not a decision tree that we have studied earlier. This is a different kind of tree, but the little bit same. Okay. This now it will use the age column and the residuals to create a tree. So it will create, I try to, so in decision tree we have read that it tries to calculate the entropy and gain to select the parent node. Similarly, a different type of calculation will happen here to select the parent node. Okay. First of all, it will try to create these nodes. Suppose it will go in, let's go in increasing order. First, it will take age 24, then 24, then 29, then 32, then 41. So every row it will create one, try to create one node. So, so when age 24, age 24, okay. So for age 24, the node is coming to be like this. Okay. If it is age 24, it will go this way. If greater than 24, it will go here. Okay. For 29 also, if I have two data, 24 and 29. So it is 2.5 and minus 56.75. Okay. So if it is less than 29, it will go here. If it is greater than 29, it will go here. Okay. So here I am only creating the two, I'm showing you two nodes. Other than that, this 32 and 41 will also be created. I'm not showing that here. Okay. So, okay. So the nodes are now created. Then there is something called similarity score and gain. Okay. Similarity score is formula is sum of residuals whole square divided by number of residuals plus this is lambda. It is also called a regularization parameter. I'll tell you what is that. Let's now for now let's take it 0, and the gain. Gain is left leaf plus right leaf minus the parent. Okay, this is the whole formula, and this is the whole calculation of uh, each every node that I have done the calculation here. Uh, Similarity score. As you can see here, it was similarity score of this one minus 56.25, and this is the left one, this is the right one. I'll try to calculate score of this, score of this, and this. Okay, this calculation I have done here. Okay, minus 56 whole square, and it is coming to be 3164. Of the right side, I have taken the these are the residuals, and this is the score. And the gain formula, this is the gain formula, and gain is coming out to be 4237. Similarly, I have calculated for age less than 29 also, and the gain is coming out to be 2900. Similarly, we have to find out the other two rows also that I have not shown here. Okay, so now when I have written here also the gain and scores. So this is coming so here the gain for this node is 4237. So whichever node gain will be highest, we will take that as the parent node. Okay. So suppose let's take that to age less than 24 is having highest gain here. Okay. So now my tree is created. So now 50% of the work of my second week learner is done. Actually, this I am not showing more further here. The other two columns were also there, and so I am not showing that here. So that's why it is looking a short one. Okay. So next, half work is done. Then now very important points to know. First one is pruning. Okay. Pruning. What is pruning? Pruning is actually it means that we can decrease the depth of the trees, or I can say that we can shorten the depth of the trees by assigning a gamma value. Okay. Gamma value where we have okay, so gamma value where we have used uh, no, not gamma value not used here. Suppose we are if I'm assigning a gamma value, so gamma value we are assigning a gamma value during the hyperparameter tuning. Okay, suppose what it will do is uh, this gamma will start from the bottom of the tree, try to move towards the parent node of the tree, and at each node it will try to do one calculation, that is gain minus gamma. It will try to do this calculation. Okay, suppose at this node the gain, how much is this gain? Gain is 2900. Suppose I have assigned my gamma to be 3000, and here the gain is 2900. So 2900 minus 3000 is giving me minus 100. So the answer is negative. So whenever this situation comes that this calculation is in negative, what it will do here, it will just uh, cut this branch or node. Okay, this will be detached from here. So now you can understand that. So it is helping us to reduce the overfitting by decreasing the depth of the tree. Okay. Similarly, this is lambda. It is a regularization parameter, and it is, as you can see, it is used here in this formula. It is used here. So from this formula also you can understand that it is inversely proportional to the similarity score and gain. Okay, this lambda also help us in will also help us in reducing the overfitting, but also has some chances of underfitting also. Okay, suppose if I give my gamma value as suppose 5000. Okay, my highest gain is 4200. If I give 5000, then my whole tree will be deleted, and the prediction will come as the only the what the my first week learner gave me, that is 77.75. Okay, so yeah, this is a very tricky situation. We have to uh, be very careful here. Then uh, then what happens? So how I will get the output? Okay, now my work is done, my tree is created. Now my second week learner is ready to give me some output. Okay, suppose I'll show you how to use this tree for this output calculation. Okay, suppose 30. Suppose input is coming that suppose the age is 30, what will be the salary? Okay, so a 30 is not less than 24, so it will not go here. It will go here. 30 is greater than 29, so it will go here. 2.25. Okay, so actually work is not over yet. This is not the final number. I will tell you what will happen here. Suppose if 26, it will go here, then it will move here. Okay, this is the formula. So if there are two nodes. Okay, so sum of residuals 12.25 plus 42.25 divided by 2 plus 0, it will be 27.25. There is a something called eta, that is also known as learning rate, that will be multiplied with this value. Yes, this is the okay. This is the eta. Okay, 0.3. 0.3 is actually the default value of the algorithm. You can take 0.1 or 0.2 also. Okay, this was the value we were getting from the tree, and we have to multiply it with 0.3, the eta value, learning rate. Okay, so but this is not our final prediction. The final prediction formula is this. The old value means the prediction given by the first or the previous week learner plus eta into the prediction of the present learner. Okay, so 24, 32, 41, the data set, the training data set that we have. So after calculating, I am getting these numbers 60, 78.425. Okay, this 77 was the first week learner's prediction, the mean. Okay, so I'm getting these numbers. So now my table will be looking something like this. So, okay, this was the prediction of my first learner. This is now my new prediction done by the my second week learner. Okay, what it is showing me. So you can see from here the error is now decreased. It was minus 56, now it is minus 39. In every row, the error is decreased, and the number is increasing towards the actual data. It was 77.75, now it is 60. So it is moving towards the data. 78.425, it is moving towards 120. And this row also the same thing is happening. So now you can see here. So this is not the final process. This whole process will go on. Okay, now until here the work of the second week learner is over. Then now this again, this age column and this residual one will be given to the third week learner, and the whole process will be done similarly. Okay, until we get a low bias model. Okay, gradually the errors will be decreased and the prediction will move towards the actual data, and at last we will create a low bias model. Okay, so this was all about the XGBoost working. And if wait, I have done the Python implementation also. Let me show you. Is my Python notebook visible? Okay, so this is the Python implementation that I have done for XGBoost. So actually, it is not present in the sklearn, so we have to install it. And here I am loading a data set, and I'm trying to compete with it with random forest and gradient boosting. So actually, I have done this hyperparameter tuning. Let me first remove it. Let's try to. Okay, so let's see. Let's see what we get. Okay, so you can see that it is XGBoost is giving me 38. Okay, random forest is giving me 49, and this is giving me 44. So here actually the trick is a random forest will every time without any hyperparameter tuning it will give you best score. Okay, always random forest will be giving you very better score if you are not doing hyperparameter tuning. But XGBoost works very well if you know how to do the proper hyperparameter tuning. Okay, so when I do this, uh, okay, now this will give me a different value. Okay, at some point it was giving me even 52. Wait, let's see. Yes, it is shooting up to 50. Okay, we have to do some. If I do a better hyperparameter parameter tuning here, it may increase from here also. At some point I got here of 0.52, but I don't know, it is not giving me anymore. But yes, this is the uh, whole implementation. And XGBoost advantages of this XGBoost is it is actually very fast. It is a high performer, and it is also compatible with a lot of I can say languages, C++, Java, Julia, and all. So okay, so so any questions, any doubts do you have? You can ask me here. Okay, so no doubts. Okay, I'm ending this meeting. Thank you.